in this question, we're going to focus on actually solving for an angle here. Okay? So in the other ones, we were solving for sides. Okay, good. And the other ones we're solving for sides. This one we're actually going to focus on solving for an angle. So this will be a little different than what we were doing before. We're still using those same primary trig ratios. So we have our SOH and TOA, as you guys know it. And we're going to try to figure out which one to use by just looking at this question. So we have an angle, and I have two measurements of a side. Okay? Now, this side is a side not touching the angle. So how can I label that side? What would it be called? Opposite. That's right. That would be considered the opposite side. This side does not touch the angle at all. So in order to be the opposite side, it cannot touch that angle. Now, the hypotenuse is always in the same place in every right angle triangle. What angle is it opposite of? That's right. It's always opposite of the 90 degree. So, because it's always opposite of the 90 degree, we're going to label that one. Which really should be the first one we're going to go about labeling, okay? There we go. So we've labeled that on the hypotenuse, which means when we form an angle, there's always going to be two sides touching it. One of the sides will always be the hypotenuse, so as long as we can label that by deduction, what's the last side going to be called? That's right, that's the only one left, so that's going to be our adjacent side. Already got it? Okay, let us go slow though. So, we already know that this is going to be the adjacent side. So let's talk about the actual measurements we have. We have the measurement of the opposite side, and we have the measurement of the adjacent side. So what I'm going to do is I'm going to look for which ratio uses the adjacent and opposite side. We know sine is going to use the hypotenuse, so that means sine won't work for us because we don't have the measurement of the hypotenuse. Cosine is also using the hypotenuse, so that won't work for us because, again, we don't have it. What's the only side we have? Yes, tangent deals with opposite and adjacent, so we're going to set that up. Tangent theta is equal to the opposite, which is what measurement? 2.5 divided by 1.3. Good. Now I'm actually going to get a value for that. I'm going to divide those two, and we have tan theta, which stands for the angle, is equal to 2.5 divided by 1.3, 1.923, okay? 1.923. Now, is that what the angle is? No. No, that's not what the angle is. The angle is represented, I'm going to ask you in a second, okay, Sam? The angle is represented by just theta here. So in order to actually figure out that, what do I have to do, Sam? That's right, we have to invert tan. So think of it like this, we're bringing tan to the other side. So theta would be equal to, and when we bring tan to the other side, we have to do second function or inverse function. And it looks like that. Tan inverse, so tan to the power of -1 to that value. So on your calculator, you probably have to hit shift of some kind. I think mine I have to do inverse. Yeah, there you go. Where is tan? Is this it? 62.5, is that what you guys got? Perfect. So this angle is 62.5 degrees. Right, that angle there. But let's say they actually asked us for all the angles. How many angles do I have the measurements of? 2. I have 62.5, and this one is what? 90, that's right. So we always know a triangle is going to add up to what value? 180. So what I'm going to do is 180 is equal to, and I'm just going to name the sides. We're going to call this theta, we'll call him A, B, and C. Okay? So A plus B plus C is equal to 180. We know A is 62.5. B is our unknown, the one we still don't know. And C is how large? 90, that's right. I called C 90. So, how can I isolate for B? What would I have to do with these two other values? We bring them to the other side, right? We want to isolate B, so we get 180. When I bring over 62, it becomes negative. When we bring over 90, it becomes negative. It's equal to B. Okay, let's take up another question here. They've given us this triangle here, and they've asked us to solve for the hypotenuse. So let's look at the information they've given us. We do have an angle. That's great. We've been given the measurement of what side in reference to that angle. That's right, that's the adjacent side. Now technically both of these are touching, but this is the longest side, which makes it the hypotenuse. So we know this is the hypotenuse, and this is the adjacent. Which ratio deals with hypotenuse and adjacent? Cos. Remember, cos is CAH. So in other words, we're doing cos theta is equal to the adjacent divided by the hypotenuse. Now, theta, which represents an angle, we have the measurement of 43. So we're going to plug in 43 for that value of theta. So we have cos 43 is equal to the adjacent is 43 inches. That's fine. We're going to plug that in for the adjacent. And the hypotenuse is known as h. So we're going to plug h in for that. So we're going to get 43 divided by h. Now this is a little different from what we were doing before. I can't just get h by itself by bringing 43 over. Okay? Many of you guys are multiplying by 43. That won't really work. I want you guys to think of turning both of these into a fraction. How can I get rid of the fractions if we have two equivalent fractions? That's right, we're going to cross multiply. Okay? So let's think about cross multiplying here. That's going to leave us with h times cos 43. And what is 1 times 43? It's just going to be 43. So really nothing else to write there. Now remember, the goal is to get h by itself. Is h by itself right now? No. So how would I move that cos 43 the other side, Sam? Who knows? Trey. Who can answer this for me? Divide it. We're going to divide it by 43 because this is h times cos 45. There's that many steps to this question. I can show you a couple other ways. Hold on. So we bring cos 43 over. That's going to give us h is equal to 43 over cos 43. So, anybody have this as an answer done on their, what is it? 89? So our hypotenuse is 89 inches, which we know makes sense because the hypotenuse is longer than this 43. So that is a logical answer for what we're doing here. Sorry, we had a small error. This should be 58. Which is fine. That's still longer than the other side and still logical. So 58 is our hypotenuse. Thank you, guys.